Hi, welcome back to the Cuzzy Sound channel and part 28 in the series all about my Project XII DIY modular analog synth. Now the module this time round will basically generate noise. In fact, it will generate 3 different colours of noise: white, pink and blue. White noise is all frequencies all at the same time. And the way that we generate that is nothing new. I've actually used this circuit before, way back when I did my first Project XII modular synth. It's a very simple transistor circuit. There's lots of examples of it out there on the net. In order to get pink noise, we send the white noise through a low pass filter. And yep, this time round I'm using a passive low pass filter, pretty similar to the one that was in Project XII. And then to get blue noise, we send the white noise through a high pass filter. Again, very similar to the one that I used in Project XII. Again, it's just a passive filter. Now if you want to technically correct pink and blue noise, you tend to go for a 6 dB per octave cutoff on the filtering. What I've done, I've got variable cutoff because I want to be able to vary the pinkness and the blueness of the noise that comes out. So most of the time I won't be getting what is technically pink and blue noise. I will be getting pinkish and bluish noise. But hey, that's what I'm aiming for. Okay, so let's go and have a look at how we put the circuit together to generate the colourful noise. This is the circuit diagram. In the bottom left there is the transistor. You will notice that the collector leg isn't connected to anything. This is how we get the transistor to oscillate and generate white noise. Now the level of the white noise that's generated is a little low for what we would normally want in a modular system. So we boost that up with the op-amp arrangement there, and then we get jack output for the white noise. Taking a copy of that white noise and moving up the diagram there, we have a passive low pass filter, and then there is another op-amp there to boost the signal back up, because the point is when we stick the signal through the passive low pass, we take away some of the signal, so we have to boost it back again to get back into something that is a good signal, and that gives us our pink noise. And twiddling the cutoff on the filter there with the potentiometer will alter the pinkness, if you like, of that. And then another copy of the white noise is taken up a little bit further, and there we have a high pass filter, another passive high pass filter. Now this time I've not boosted the signal, I've buffered the signal with the op-amp, so it's just a straight connection from the output to the inverting input there. But that gives us a blue noise output at the jack socket there, and the blueness is altered by twiddling the potentiometer. Now all of these circuits, the white noise generator, the passive filters and things, I've used them all elsewhere before, I've just not put them all together in one circuit. So what does the stripboard layout look like? Well, the stripboard layout looks like this. A couple of things to note. It's a dual rail power supply, so there's minus 12 ground and plus 12 volts. That's down on the bottom right of the board there. You can see the transistor down on the bottom left there, and you can see underneath the collector leg that I've made a track cut. I needed the track cut there anyway, because that's also where the minus 12 volt line runs. But the advantage of having the track cut under the transistor leg means that that dangly leg isn't likely to short out on anything and mess up the white noise generation. And then the op-amps is the TL074, which gives us all the op-amps that we need. So yeah, fairly straightforward. And when you put it all together, the circuit looks like this before it gets onto the panel. So there's not a lot of components. It's fairly compact, so it's relatively easy and fairly cheap to build. But what does it sound like? Well, let's go over to the synth and have a listen. This is the panel in the synth. So we've got the top socket with the white lead is the white noise. The next socket down we've got the pink noise, and the pinkness is adjustable with the potentiometer. And then we have blue noise, and again we have the potentiometer for adjusting the blueness. We've actually got a little bit of noise coming through there. Okay. Right, we'll start with everything turned right down on the mixer. So all I'm actually doing, I'm just taking all three of the noise signals out into the mixer, so I can kind of dial them in one at a time. Okay, we'll start with white noise, which is the basis for everything else anyway. Had a little bit of effect turned in there. We'll not play with effects at the moment. So this is just the straight white noise. Now what you could do, you could take that and pass it through filters, you could pulse it. In fact, white noise is used in a lot of the percussion modules to generate hi-hats and snares and things. So yeah, it's in itself it can be quite useful if further processed, or just use it as a sound effect. Okay, we'll try the pink noise next. So that's going onto the pink lead. So if I dial up the pink noise, now as I adjust the pinkness, we should hear the higher frequencies dropping off. Until you've got pretty much most of them have gone, and we now got quite a low frequency output. Because as I said, when we're looking at the actual design of the circuit, we're saying that because these are passive filters, the more you kind of dial up the cutoff, the more you lose some of the signal. But there you go. Pinkish noise with adjustable pinkness. Right, the last one is the blue noise, which is going down there. So bring in the blue noise. Already you can hear there's some of the filtering has already happened and taken out quite a few of the lower frequencies. And if I turn it up, not as noticeable as the filtering on the pink noise, but you can hear you're starting to get a lot more of the fizzy top end as you turn the filtering right up. But of course, what you can do, because we've got all three being generated at the same time, we can start and mix them. So bring in some pink. If you heard a crash, that was me crashing into a stand that's just behind me. Sorry about that. Then of course you can start and add in extra effects. So let's add in a little bit of ambient effect. So we're bringing ambient effect in. I've thrown a bit of ambient effect in onto the blue noise. Now bring a bit of ambient effect in onto the pink noise. And we can play around even further. What I do actually have, if I'm taking, I can't quite see this, it's off the bottom of the screen, but I'm using auxiliary send and return to take the mixed signal from the mixer out and through an MS-20 low pass filter, a voltage control filter. So I'll dial in the effects send and return, and then we'll hear what we can get when we play around with that. That's me adjusting the cutoff manually. But what if I use a looping envelope to adjust the cutoff? Well, lots of fun effects going on there. So yeah, it kind of environmental and ambient effects, and it's just one example of what you can do when you start blending different colours of noise. I'm sure there's plenty of other things I could do by passing all of these signals through different modules and playing around, pulsing them using VCAs and further VCF and envelopes, all sorts of things. So yeah, lots of fun. I will put the circuit diagram and the strip board layout in the Cuzzy Sound Dropbox. Link for that down in the description, so you can go and get a good copy of those. And you've seen how simple it is. You've heard what it can do. So if you want to play around with the colour of noise, then go on, have a go, build your own.